So hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back again with another great MATLAB based project, and which is a HVDC offshore wind turbine. And here you can see here it is just a basic overview of the projects. This is the simulation file that you will get from the description box, and I am just giving you the overview how the project is working. So yes, there is a wind turbine which is 11 kV which generate wind turbine which is connected with the 11 kV alternator. You can see here wind turbine which is located inside the sea, and then this 11 kV is generated, and then it is a step up to the 100 kV. Then this step up AC voltage is converted to the DC voltage because we wanted to transfer the power at the DC supply. With the DC supply we are getting more efficiency compared to the HVAC system, and losses are also less, and the conductor length and numbers of conductors are also reduced when we are using the HVDC system. So yes, so this is a control rectifier part, and then the battery part, and then this is cabling 100 kilometer cable which we have considered for the sake of simplicity. And yes, then there is a substation which is located at the bank of the sea, and yes, obviously we are getting the DC power, and to convert this DC power to the AC power we require the VSC controller. I have used the VSC control technique to synchronize it with the grid. So this is the grid that I have synchronized with, and this is the load which is household load which is on the 415 voltage. So yes, this is how the basically the overview of the simulation is look like, and the images are also placed, so you will get the better understanding. So right now we are switch over to the simulation part, how the simulation is working. So for sake of simplicity, before running the simulation I have added this code. What you have to do, you just need to copy this code, sorry. So you need to just copy this code and place into this command window, and yes, obviously this part is not there. So you just need to place this part and just press enter. You have saved some values TS control and TS power, which is used to control our rectifiers properly. So yes, make sure before running the simulation you have added. So this error which was previously mentioned is now fixed. So you need to fix the error. So once you fix everything is okay, now the simulation is okay and you can run the simulation. So I just save this project, so everything is okay right now. And yes, it's obviously take time to run the model. I just save it, and the battery backup system is also there to support the power during the switching of the rectifier. Okay, so I start the simulation, and we will check everything, how the system is working and what are the parameters that you have to check while you are trying to run this simulation. So yes, it takes time because there's a lots of calculation that is uh, carry out parallelly when you are running the simulation, because there is a lots of complex circuits and complex calculations, because we have added inverters, we have added rectifiers, we have added battery. All the things are there in the simulation, so it is taking too much time while we are trying to run the simulation. So we need to just wait. Okay, so you can see that. the simulation is started to run, and the different parameters are also displayed. Once it completed 0.02 second, once the simulation is completed 0.02 second, all the RMS value will be displayed. So right now, yes, this is the turbine which is feeding the 10 meter per second is input, and 1.2 is the speed, and according to that we are getting some output, and that is used to generate 11 kV voltage. After some times we are getting the voltage, exact value of the voltage and current, because right now it is a RMS value, so it's required one cycle, at least one cycle, because one cycle is required to measure the RMS value. So we need to wait for a 0.02 second because our system is on the 50 hertz, 11 kV 50 hertz. Then we are updating it to the 100 kV, and then the rectifier is there, control rectifier. There is a PID controller is also there. This is a maximum voltage that we wanted to maintain. And yes, you can see this is a battery, and initially battery might get discharged, but after some time it gets charged once the satisfactory voltage come across the output of the rectifier. Okay, so yes, then this is the you can say cabling part, and this is the inverter part. So right now we just have to wait for some time because it take too much time to simulate. So you can see that simulation is run 0.023 seconds, and for that you can see different values at the RMS block. You can see this is the ampere, and this is the voltage that is we are getting from the grid is 11. Then we are step down the voltage for the 415, so we are at least getting 441 voltage, which is nearly getting at our home when we are taking the three phase supply from the grid. So three phase supply is not just a 415 voltage, it is vary from 400 to 440 voltage. So yes, we are getting satisfactory voltage, and we are getting satisfactory voltage for our load as well. So you can see 14 ampere is taking by our load, and 440 voltage is our actual voltage. So if you want to measure the waveform, you can measure by just double clicking over the scope. And if you clearly wanted to measure, then okay, so you can see this is the waveform uh, that we are getting uh, at the load end. So you can see it's a very clear sine wave that we are getting. Okay, and if you wanted to check at the output of the inverter, you can check voltage and current. There is slight higher ampere because of the circulating current is flowing in between the grid and the system, synchronizing, because we are synchronizing grid and the inverter, because we are trying to synchronize both. So that's why we are getting slight higher ampere. And here you can see the higher voltage 600 voltage, but it is the instant value. If you want the exact value, RMS value, or you can say the value that we are getting through our meter, our MFM meter, multifunction meter, is this one, and this is the instant value. That's why it is slightly higher. So yes, simulation is run for the 0.03 second. I just stop it, otherwise taking too much time and it's taking too much load over my PC. And yes, you can see if you wanted to see the battery, initially battery may get discharged, but after some time it gets charged. You can say after some time it gets charged. How I can say it gets charged? Because the current taken by the battery is negative, which it represent that initially get discharged but then charge. But if you wait for a long, you can see the slope will go upward. Okay, so yes, batteries help us to support the system due to any variation, or whenever you start the system in initial stage, for initial amount of time, whatever the power is required, that is fed by the battery. So it is work as a stability, work like a stability system. So yes, this is how the HVAC DC system located at the offshore is working. You can consider this for your BTech or MTech project, or even PhD as well, because lots of thing is cover, lots of grid synchronization is cover, control rectifier is covered, and the wind system with the 11 kV AC turbine is also covered. So if you want this file, you can connect with me through my email ID that is given in the description box. Thank you very much. Thank you for watching this video. If you have still any query, just comment it. I will definitely reply. For any type of MATLAB project, you can connect with me through my email ID that is given in the description box. Thank you very much.